And the last of our speakers today is Manfred. So, Manfred, I had to call Carmen because we are honestly ran out of creative and introductions for you. You've been here every year, and I don't know what to say. But where's that round of applause? Thank you.
Yeah, thanks for having me. So I guess if you think about your own code base, you quite often think about something like a script. A script you might know from making a movie. A script where you can read line by line what to do or what should be done. And this metaphor is not wrong. This metaphor is really okayish. However, if you want to succeed with signals, you really need to switch your thinking. Because the thing is, when we use signals, we are using reactive programming. And this is quite a shift in paradigm, isn't it? So instead of thinking about a script you go through step by step, you should think about a marble run. A marble run where several marbles go through, and those marbles represent your data flow. And every time a marble passes a certain station, the marble can be changed. Sometimes even a marble can be split into several marbles, and sometimes several marbles can be joined to one. And what we get at the end of this data flow is some result we want to present to the user. Usually, we do this with data binding. I know there are other ways, but the preferred way in Angular is data binding to present something to the user. And this change in thinking is what this whole presentation here is about. For this, I've prepared several things for you. I want to get started with computed signals. Then we will talk about the brand new resource API and about linked signals. We will proceed also with effects and reactive helpers. And out of this, I try to distill 3 rules of thumb. Rules of thumb that help you to succeed with signals, to more effectively use signals. Before we start, let me introduce myself. I'm Manfred. I'm a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. In this role, I'm helping a lot of companies. I'm visiting them. Sometimes we are doing remote, and there we are doing trainings and consulting and reviews. And besides this, I'm also quite connected to the Angular community. I live in Austria. I do a lot of stuff in Germany, and I'm always happy to work together with people around the globe. We are quite present, meanwhile, in whole Europe, and sometimes we are doing stuff for people in the US or in South America. Okay, cool. So let's get started with the first topic. It's a very underrated topic. I know you are thinking now, computed signals, it's so boring, but no, this is really the backbone of your reactive data flow. This is the backbone of your, as I call it, marble run. So let's have a look into an example and how we are using computed signals in there. So this example is quite tasty, if you ask me. It is about Austrian desserts. And you know, we in Austria have a huge amount of different desserts. For instance, we have Sacher cake, we can rate it here, or apple pie, Apfelstrudel, or Palatschinken, our style of pancakes. So Palatschinken, I've researched this, comes from Eastern Europe. It landed there from Latin, and it basically means cake. So it's not that a bad term for pancake. However, the thing is, while Palatschinken pancakes are awesome, ice cream pancakes are the best. And here I have a dilemma, because 5 stars is not enough here. 5 stars out of 5 stars is not enough, and that's why I can double click the 5th star to enter the cheat mode. Look here. And then I can give up to 500 stars out of 5 stars, because if it comes to ice cream pancakes, mathematics does not count anymore. So what do we have else? We can search here by the original name, Palatschinken, or by the English name, pancake. and then we get the result, and we can load some expert ratings, which are actually mine. So if you once come to Austria, you immediately see what you should try in terms of deserts. Okay, this is my demo application. If we look into the source code of this, we see the source code has a desert component, and this desert component is already using signals. Everything that is data bound is a signal here. For instance, the filter original name and English name, then a flag for the loading spinner, and the deserts. Also, the ratings are a signal. Both is here in a signal, and now the best comes. Both is flowing into a computed signal. That means every time deserts is changed or ratings are changed, these computed rated deserts are recalculated. And so we are always up to date. You can really imagine this as two marbles going into computed every time this or that marble is changing, and so we are kept up to date. Architectural-wise, you could call this a view model. A view model that is always up to date. You don't have to think that on this event and on that event and on this further event over there, you have to update your data. No. And so you cannot get inconsistencies or redundancies. This rated desert signal is then data bound, and that's it. Okay, so this was a first simple example. And as mentioned here, we quite nicely see this idea of the marble run of the data flow. We might have a purple marble and a pink marble, and both of them go into a computed signal. However, there is a little tiny issue. Namely, we don't start with the deserts and the ratings. All of this starts with the user entering some search criteria bound to original name or English name. That means somehow we need to bridge the gap here. Somehow we need to take this data whenever it changes and load our deserts. And the thing is, so far, this was not possible in the signals world. You could cheat a bit, you could trigger a script, an event handler, a click handler behind the button to load the stuff, and then you could have gone on with the signals here. Or you could have switched over to RxJS. We have quite a nice RxJS interop to bridge the gap here. But in the signals world, there was no real solution. And that's why I'm really happy about the new resource API. Because while the resource API is just a little tiny function, or perhaps just a bunch of functions, it is really bridging this gap. It allows us to have an end-to-end marble run. So what is this resource API about? Mathieu Riegler already mentioned it today. It has currently two properties. Perhaps we get some additional in the future. The first is the request. The request is just a signal, and every time this signal is changing, the loader is triggered. That means we see at first glance when loading some data is triggered, only when the request is changing. And then the loader is responsible for getting your data. And for this, you see it here, we go down a very simple road. We just return a promise. No observable, just a promise. It's really a very, very simple solution here. Saying this, there is also a so-called Rx resource that is doing the same with observables. The loader here gets this parameter object. Parameter has .request, and this contains all the values from our request signal. And now we see how all of this nicely fits the marble run. We have the deserts criteria, which are just a composition of the other two criteria, English name, original name. Both go in there. Deserts criteria go out. Deserts criteria go in the resource, and we get something out, namely the resource value that is then sent to the next computation. And so we have a nice end-to-end data flow. This is quite nice, but there is another thing that is also worth to mention. The resource API can deal with race conditions. Just imagine someone is searching for pancakes. And then before they get their result, they are searching for Sacher cake. And before they get the result, they are searching for ice cream pancakes. So usually you would expect to only get the results for the last one, for ice cream pancakes. It would be quite confusing if those intermediate results would blink up. And it would be even more confusing if searching for pancakes took a bit longer. Because now we really have a race condition. Now everything is blinking up and the user sees the intermediate result in a strange order. At least strange for him or her, because it does not correlate with the order of the requests. In traditional Angular, with RxJS, we solve this issue usually with a switch map. And the resource API also has the same semantics baked in. The resource API always uses switch map semantic for loading data. So this is one issue we don't need to think about anymore. It's solved underneath the covers. Let me show you an example for this. For this, let me switch to the next branch. It's this one here. Here we go. Let's reopen this. And here we see that we start with our criteria, original name and English name. Then both is flowing into the deserts criteria, and then both is going in here into our resource. The deserts criteria is triggering the loader, and the loader has some squiggles here. I don't have any idea why we have squiggles here. Seems to work. But in there, we see that the loader is triggering here a method, and the method gets our parameters. Param.request, if we look at this, there seems to be an issue with the code. Let me quickly try to restart this. Oh, okay. Oops. Desert. Where is it? Let me quickly try to open the desert component again. Anyway, does not matter. This request here is more or less the representation of our deserts criteria with English name and original name. And you see something else here, an abort signal. So this is really interesting because this abort signal allows you to tell find promise to abort the current operation. So perhaps resource found out that we don't need this operation anymore because the user changed the criteria. And so it would be nice to tell find promise to stop the operation. Of course, for short-running operations, this might not be always necessary, but you want to have something for operations that take a bit longer. And for this, you can pass in this abort signal, the resource API created for you. But even if you don't use this here, this abort signal, you won't end up, you will not ever end up with race conditions, because if it is not aborted, it will be ignored by the resource API. So this here is really straightforward to use. And then we are going on. Then we can use the value of our resource to compute something. Here I'm computing in a default value. Perhaps in the future, the resource will give us a default value option. Currently, we have to do this with computed and so on. And then I can go on with do rated and computed. My deserts are going in there, and the ratings are going in there, and the results is my rated deserts. Besides this, I can also ask the resource if it is currently loading. This might be the right information I need to display a loading spinner. And I can ask it if there was an error during loading. There is also this error signal I can use to display some toast message with an error. Okay. This nicely helps us with this end-to-end data flow, and this brings me to my first architectural rule of thumb, which is derive state wherever possible. This is completely in the sense of reactive programming of this paradigm we need to switch over to. Because if we derive values from existing values, we are always up to date, and we cannot get any inconsistencies and redundancies. And to do this, we can use computed for a synchronous derivation, and we can use the new resource API for an asynchronous derivation. So now we have everything for deriving our state. There is another thing that helps you with this idea of the data flow. It's also quite new now. It arrived in a developer preview with Angular 19. It's the linked signal. So what is the linked signal about? Well, look at this simple example. Here I'm injecting a store, and this store has a property original name. And as usual, if you work with a store, the data you get is read-only. However, sometimes we want to data bind such data to input fields and so on. And this might look okayish at first glance, because we all know ng model is supporting signals. However, it won't work because it's read-only, isn't it? And we have this issue not only for stuff from the store, but also for computed stuff, because obviously the result of a computation is also read-only. And this is where the linked signal comes in. At first glance, it looks like a computed signal. And yeah, underneath the covers, it is using computed. However, it also has a local working copy. And this local working copy is what you are binding here. That means you're getting the data passed down via the flow, you get it copied into this writable working copy, and this is what you can data bind. And then when the user clicks on save, you can take this working copy and send it back to the store or do something else with it. Let's also talk a bit about effects and reactive helpers. There was a lot of discussion in the community about using effects or about not using effects. Some people say you should never use it. I would not go that far. But sometimes it's perhaps better if you search for other ways. The thing is, effects are mainly for connecting the reactive and the imperative world. The world with the data flow and the world with the script. And usually this connection happens at the end of your marble run. You are doing something in the marble run, the data is derived and derived again, and then you want to trigger a script. For instance, you might want to display a toast message. This is not done via data binding. This is done by calling a function or a method. This is a good use case for such an effect. The Angular documentation mentions 4 ideal typical tasks for effects. For instance, drawing on a canvas. Obviously, drawing on a canvas does not work with data binding. Or manual DOM manipulations. Perhaps you have a charting library or a nice toast library that needs to directly manipulate the DOM. It's about logging to the console, logging back to the server, and perhaps it's also about syncing with the local storage. So more or less, you can sum this up as some kind of rendering or similar tasks. Of course, not all of this is rendering per se, but it's rendering in a broader sense. In a broader sense, in the sense of writing something into a sink, writing something to the destination of the data, which is quite often the DOM itself, but it can also be the local storage, the console, the server. But it's always at the end of your data flow. So for the sake of simplicity, let's go with the word rendering. And another way to look at this is the effects are always for stuff you cannot achieve with data binding. So let me show you an example for this. Let's switch over to the next branch. Force checkout. So hopefully it works now again. Let's cross fingers. Yeah, it works. And here already see the first effect of my effect. You see here this guy. This toast message popping up every time we get a new search result. For instance, a search result for palatschinken. So how is this implemented technically? Well, here in our constructor, we have two effects. The first of those effects is writing out the search criteria to the console. Every time I'm changing the criteria, something is written out to the console. And here we have a second effect. Every time my test certs is changed, I'm showing this toast message, XYZ test certs have been loaded. And also this is something we need to do with a script, with a method call. So both of them are ideal, typical tasks for an effect. Let me prove that both works. We have already seen the toast message, and now let's have a look at the console, and let's here change the criteria. And as you see down there, every time I'm changing the criteria, I'm writing something out to the console. Awesome. So this looks quite nice. However, there is some behavior you might not have been expected. Look at this. Let me take those two lines of code and let me refactor them into a function of themselves. Extract to function, to method is okay, log stuff. So now at first glance, you don't see that this effect is doing something when the original name or the English name is changing. At first glance, you only see, oh, there is log stuff and there is no signal involved. However, underneath the covers, inside of this method, we see that we are accessing original name and English name. And guess what? This outer effect will also track the signal in there. Let me prove this. It still works, still the same behavior. And this might be a bit spooky for you, because now you see some source code and you cannot tell at first glance what it's doing and when it's repeated. However, if we think about what I told you before, that effects are mainly for stuff that is a bit like rendering, then this makes really sense. This so-called auto-tracking now makes a lot of sense. Because when we talk about rendering, you are rendering the stuff out initially, and then when one of the things you have touched is changing, you need to re-render it. Every time it is changing, you need to re-trigger the rendering, and this is exactly what happens here. And this shows here the Angular team really had such use cases in mind when they implemented effects and auto-tracking. So for rendering, it really fits. However, just think about calling a business logic there. Something like this.store, do stuff, calculate something, and so on. This would be counterproductive because your business logic is in a different layer of your application. And usually you treat it here as a black box. You are not interested into whether this function is loading or using a loading signal or a user ID signal. You are not interested into this. However, because of auto-tracking, if those signals were used, the effect would automatically rerun when someone else in the application would change the loading signal or the user ID signal. And this is something you for sure don't want to have. You don't want to re-trigger this effect when some other logic is updating those signals. And this shows that for business logic, or logic delegating to business logic in the backend, effects are not the right choice because of auto-tracking. And also, please remember what I told you before when we discussed resources, also because of race conditions. So the effect alone does not help with race conditions, which also might be an issue here. This brings us to my second architectural rule of thumb, namely avoid effects triggering business logic. This is not what they are intended for. But if you tell you don't use affects for triggering business logic, the first question that comes up is, what should we do instead? And the answer is, instead, you should go with reactive helpers like the resource API. There are also other reactive helpers out there. The NGRX team really does a great job with providing reactive signal-based stuff. There is this NGRX signals package with the signal store, a very lightweight, extensible signal-based store, but they also have other helper functions in there. And besides this, we have ngx extensions, which is also an open source library with quite a lot of helper functions, and you can even implement your own. So let me give you an idea for such a helper function by showing you another example. So here we go. This example is almost the same as before, but now we have here a details button, and this details button gives us this beautiful details view. And you see, you can here navigate back and forth. You can navigate through all your deserts. Now let's have a look into the source code. For this, let me switch over to the deserts detail. So in there, we have here an ID, which is an input, a so-called signal input. So technically, it looks like a read-only signal for us. And here we have ng changes. Every time this input, this ID input is changing, we are grabbing the current value, we are reading the signal input, and then we are sending this ID to the load function of our store. For us, the store here is a black box. It's just some store with methods we can call, and it also gives us some signals. This looks great at first glance. However, using a hook like ng changes is not really reactive. It's more this old style of programming where we have some callback and we wait until someone is calling this callback. And the truth is that in the future, the Angular team will give us those new signal components, a kind of component that is fully signal-based. And this kind of component will not have a ng changes callback, because instead we can use all the other reactive mechanisms that are now in there in terms of signals. So sooner or later we need to switch away from those lifecycle hooks. But you don't need to worry that classical components will still be there, but you will get another kind of components immediately, eventually. So the big question is, how can we compensate for the lack of this future ng changes? Well, we could try something. We could go to the constructor and we could spin up a new effect that is calling this here. However, now we have the same issue as before. We don't know which signals are used in there. If there is a loading signal used in there or the user ID, then the effect would also track those inner signals, and this is something we don't want to have. Also, there is no official way for dealing with race conditions, so this is not the best solution. However, you can do something if you have NGRX signals. With NGRX signals, you can define so-called reactive methods. And the reactive method is a method that takes, for instance, an observable or a signal. So now let me pass in my signal here. And the important thing here is I'm not passing in ID, I'm passing in ID, which is a big difference, no parentheses, you know. So I'm passing in the signal itself, not the current value. And this method now will subscribe to the signal, or to say the least, it will track the signal. And every time the signal is changing, it will trigger some logic inside of this method. And this gives us back this reactivity without going with an effect. If we look in there, rxload is basically a function that is set up with the helper function rx method It's an Rx method of number, and that's why we get a pipe, a reactive pipe, an Rx pipe, where a number is going through. And now we can use all the magic of RxJS to prevent side effects and to prevent race conditions and so on. At the end, we need to patch our state in the store. I'm very sorry for this. Usually a tab is used because Rx method is subscribing for us. And so we cannot put our own code into .subscribe. That's why tab is used, or tab response, which is a mixture of tab and catch error. In the future, and I have already seen the pull request, there will also be a reactive method that is not using the pipe like here. But then it's up to you to prevent race conditions, for instance, by triggering a resource. But now you might be critical with me. Now you might say, hey Manfred, this all looks well, all those helper functions, but honestly, let's look underneath the covers. Because underneath the covers, all those helper functions are using effects, don't they? And this sounds a bit like cheating, doesn't it? However, the big difference is the effect is encapsulated. It's abstracted away in a form that makes us able of using it in a safe way. I like to compare this with the go-to statement. Who has used the go-to statement in the last year? Okay, one of you. And you are laughing, so I don't think you really used it, but perhaps you have. No one, almost no one has used the go-to statement in the last year. But let me tell you something. Your CPU is doing go-to all the times. Your CPU does not know about a loop or an if condition. It just knows about jumping around. But already several decades ago, people, and I'm really thankful for this, abstracted this go-to away from us by giving us loops and if and switch and so on. And this is what I think about using effects underneath the covers. And not only I think like this, also the Angular team thinks like this. It's about abstracting the effect away so that we can use it in a safe way. Think about the resource API once again. It takes care about tracking the request, it takes care about triggering the loader, and it takes care about race conditions. So we don't have any issue anymore in these regards. So it gives us a safe way of loading stuff. And of course, if we needed to implement something like this by ourselves, we needed a lot of low-level infrastructure code. And this is nothing you want to see in your application code. This belongs into a library like ensure-x signals and so on. Okay, so we are reaching the end of this. If you like this presentation, you might also like my free ebook. It's meanwhile in the 6th edition. We have 20 chapters, and it contains a lot of those ideas. So feel free to download it here. And also, if you are a bit sorry that we are reaching the end of the day, well, there is this workshop this strange guy here is doing, but trust me, he's a nice one. And the next one is in February. And we have the early bird until December 22. So perhaps you want to step by. Let me come to the conclusion. What did we see today? So basically, I distilled out for you 2 rules of thumb that are very in handy here in order to succeed with signals. The first rule of thumb is derive state wherever possible. This is completely in the sense of reactive programming. It prevents unnecessary writes, and it also prevents redundancies and inconsistencies. Everything is always up to date. You have this Marvel run. For this, you use computed for a synchronous derivation or the resource API for an asynchronous derivation. And the second rule of thumb for your architecture is avoid effects triggering business logic. Use something else. Use some helper functions like the Rx method in ensure-x, or perhaps you bring your own. Besides this, we have also seen that reactive helpers and primitives help you to streamline the whole reactive data flow. And for this, we looked into the resource API, into the new linked signals, into Rx method, and also a bit into ng extensions. At least I've mentioned them. And there are two additional things I always want you to remember. If you forget everything about this, please always remember two additional things. The first thing is really vital. It is ice cream pancakes. So if you ever come to Austria, please try ice cream pancakes. It's the best, by far the best dessert there. And the second thing is, think about your application as a marble run. The marbles are kind of the data flow that goes through the application. This really helps you to switch over to the reactive paradigm. So that's it. Here you find my contact data. I have already uploaded my material to my blog, and follow me on Twitter, X, Blue Sky, and so on to stay in contact. Thank you.